Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's Chapter 6S, Trigonometry. Problem 1, page 688. In the figure below, what is the sum of a and b? Well, sine is equal to the opposite over the hypotenuse. So the opposite here would be b over 5. So sine of 20 degrees is equal to b over 5. B is also equal to 5 sine 20 degrees, which is going to be 5 times 0.342 approximately, so B is 1.71 approximately. The cosine of 20 degrees would be the adjacent, this over the hypotenuse, so that's equal to a over 5, so a is equal to 5 times cosine of 20, 5 times approximately 0.940, so a is approximately 4.70. The sum of a and b, a plus b, is equal to 6.41 approximately, which is answer choice B. Problem 2 on page 688. A ladder is leaning against a wall forming an angle of 50 degrees with the ground. If the length of the ladder is 20 feet to the nearest tenth, what is the distance in feet from the foot of the ladder to the wall? So the implicit assumptions here is the ground is perfectly level, just like the base of a right triangle that we see here. You can draw in the little box, or just know that it's a right triangle anyway, and that the ground forms a perfect right angle with the wall, which means the wall is perfectly perpendicular to the ground, which in real life, walls and buildings tend to settle a little bit, so they're unlikely to be perfectly perpendicular. But I digress. Anyway, we draw a diagram and we see you have a right triangle where the ladder is the hypotenuse. So this here is the ladder. The distance from the ladder's foot to the wall is the adjacent side, or A. Since cosine of 50 degrees is the adjacent over the hypotenuse, that means cosine of 50 is equal to a over h, which is a over 20. We know that a is equal to 20 times cosine 50 degrees, which is approximately 12.9, or answer choice A. Problem 3, page 688. This is the hard way to do it. This is the way that I tried it first. And okay, if 0 is less than theta is less than 90 degrees, so that means theta is in quadrant 1 if you know the unit circle, and tangent of theta is equal to 3/4, what is sine of theta plus cosine of theta? We know from the unit circle and the 4 quadrants that where an angle is between 0 and 90 degrees, sine, cosine, and tangent are all positive. You can use the mnemonic all students take calculus. So first quadrant would be all, second quadrant would be S for students, means sine is positive, T is in the third quadrant, only tangent is positive, and C in the fourth quadrant is cosine is positive in the fourth quadrant. Anyway, we know that tan is equal to O divided by A, that's the opposite over the adjacent. We can multiply that by 1 over H divided by 1 over H, so you get O over H and A over H, so that would be sine over cosine for any angle. So that's how we know that sine over cosine is equal to tangent, and therefore sine of theta is equal to 3/4 of the cosine of theta, because we can just multiply by cosine of theta, and then we get, sine over cosine is 3/4, so sine theta equals 3/4 cosine theta. We know that sine squared theta plus cosine squared theta equals 1. That's just a basic trigonometric identity. It's a trig identity for any value of theta. So 3/4 of cosine theta squared plus cosine theta squared is equal to 1. That means 9/16 of cosine squared theta plus cosine squared theta is equal to 1. Therefore, 25 over 16 cosine squared theta, we're just adding these together, equals 1. So cosine squared theta is 16 over 25. Because we obviously have to divide by 25 over 16 on both sides. Since we know cosine of theta is positive, cosine theta has to be just the square root of 16 over 25, that's 4/5. And sine of theta is 3/4 of 4/5, which is 3/5. Therefore, sine of theta plus cosine theta is 7/5. Now, despite how fast I went through that, that actually took longer to do it than the easy way, which I'll show you in just a second. Problem 3, page 688, done the easy way. We know that tangent is equal to the opposite. So here, if we're looking for the tangent of theta, that would be 3 over the hypotenuse. And so again, we can multiply it and do the same thing we did before. Therefore, sine of theta is 3/4 of cosine theta. So since tangent of theta is equal to 3/4 O over A, we can actually probably just ignore this first part and just go and say, okay, well, I know that this is 3, this is 4, so I know that the opposite over the adjacent is 3/4, so this is 3, this is 4. Since it's a 90-degree angle, right triangle here, we know that this is just going to be a 3, 4, 5 triangle. If you don't recognize that right away, you can just use the Pythagorean theorem and go, the hypotenuse is equal to 3 squared plus 4 squared. There, the hypotenuse squared, I should say. So, it's a squared plus b squared equals c squared, as we see here. So then we know that 3 squared plus 4 squared is going to be 9, not 9 squared. It's going to be 3 squared, which is 9, 4 squared is 16. 9 plus 16 is equal to 25. Square root of 25 is, of course, 5, so h equals 5. Either way, pretty easy to figure that out. Took me a lot longer to explain it than it would actually take you to do it. Cosine of theta equals 4/5, and because here's 4, here's 5, so that's going to be the adjacent over the hypotenuse, and the sine is 3 over 5, 3 over this, which is 5. So cosine of theta plus sine of theta is 4/5 over 3/5, which is 7/5. All right, let's go on to the next one. Problem 4, number 688, or page 688, I should say. What is the measure of the smallest angle in a 5, 12, 13 triangle? Sorry, I didn't put in a question mark there. I hope you can forgive me. All right, anyway. You should know that a 5, 12, 13 triangle is a right triangle. It's one of the special right triangles you should know. It's a little more exotic than 3, 4, 5 or 3x, 4x, 5x, like 6, 8, 10. But it's one that they're likely to ask on the SAT for that reason, because they know it can throw off some people. So you can either use the Pythagorean theorem to figure out that 13 squared, which is 169, is the square of 5, which is 25, and 12, 144. That is 25 plus 144 equals 169. Unless you've memorized your squares up to about 15 or 20, this might not be the easy way to do it unless it's on the calculator section. Either way, what you can do is just know 5, 12, 13 is a right triangle, and you can do a couple different things. You could say, well, all right, draw the triangle. You see, okay, the smallest angle has to be across from the shortest side, which is across from 5. So you can say, well, oh, all right, I know that the opposite over the adjacent would just be 5 over 12. That's the tangent, so all I have to do is take inverse tangent of 5/12, and that will give you 22.6. You can also just go 5 over 13, which is the opposite over the hypotenuse. Take the inverse sine of that. That's also 22.6. And Oliver, one of my students, actually pointed out the inverse tangent method, which is a little bit quicker than doing it 5 over 13, but they're pretty similar. Anyway, problem 5, 688. If triangle ABC is isosceles and the measure of angle C is 90 degrees, okay, then you know it's a right isosceles triangle, which hopefully you'll know immediately is 45, 45, 90, since if two sides are the same, the opposite angles also have to be the same, and if one is 90, means each of these has to be 90 over 2 or 45. So tangent of A equals 1. Well, that has to be opposite over adjacent. Well, okay, this is the opposite, this is the adjacent. Why? Because this is the hypotenuse. So yeah, you can see they even put the little line through here to tell you that these are equal to each other. So since both sides are equal by definition, that's what isosceles means, equal legs. Tangent of A is 1, so that's true. So sine of A is equal to cosine of A. Well, sine is going to be the opposite over the hypotenuse, so that's this over this. Definitely can tell that. And the cosine is the adjacent over the hypotenuse, this, which we can tell are the same length, or is the same length over this, so yes, they're exactly the same thing. And the ratio for 45, 45, 90, in case you're wondering, is 1, 1, square root of 2. So whatever this is, if this is 3, we know this is 3 square root of 2. Get it? Okay, so sine of A is equal to cosine of A, so 2 is true. Sine of A is equal to cosine of B. Well, okay, cosine of B would be the adjacent, which would be this, over the hypotenuse. And sine of A would be the opposite, so it's actually the same thing over this. So yes, they're it's this side over the hypotenuse and this side over the hypotenuse, so they are exactly the same thing. So 1, 2, and 3 are true, so therefore D is the answer. Problem 6. Okay, a kite string is tied to a peg in the ground. Again, just assume yes, this is perfectly flat ground, so this is going to form a nice right triangle. So here's the kite here, the kite, and directly below it form, well, it makes a nice vertical line. And so we have this. We can tell this is going to be a right triangle. So if the angle formed by the peg and the string is 70 degrees and there are 100 feet of string out to the nearest foot, how high above the ground is the kite? Well, all we have to do is we can say, okay, the sine is the opposite over the hypotenuse. That's pretty easy to figure out. So we know that sine of 70 degrees is going to be O over 100. We just multiply 100 feet times sine of 70, and that's going to give you approximately 94 feet. So note that the answer has to be the nearest foot. Isn't going to make much of a difference on the multiple choice unless they give you something like 93 and 94, so make sure you don't make a rounding error. But be careful on grid-in problems, because if it were, if it's 93.6, then you have to round up to 94. If it's 93.4, you have to round it down to 93. In this case, it's 93.96, which hopefully anyone would know would round up to 94 feet. So there you go. Problem 7, 688. If the longer leg of a right triangle is twice as long as the shorter leg, what is the ratio of the measure of the larger acute angle to the smaller acute angle? Okay, so the larger acute angle is going to be across from the longer leg. So that would be A here, since we're saying this is 2, this is 1. No, it's not drawn to scale. Sue me if you don't like it. B is going to be across from the shorter leg, so that's going to be B. So we need to find B over A. We see that B over A, well, okay, we know the longer leg is twice as long as the shorter leg, so we have this is 1, this is 2. That's where we got that from. So we use the Pythagorean Theorem. We know 1 squared is 1, 2 squared is 4. 1 plus 4 is going to be equal to 5. From the Pythagorean Theorem, we know then that this is the square root of 5. So sine of B has to be the opposite, which is 1 over the hypotenuse, which is square root of 5. So it's going to be 1 over square root of 5. So just put that into your calculator, take the inverse sine of it, and that's going to give you 26.56. Yes, you could rationalize the denominator and make it make it root 5, square root of 5 over 5. But you don't have to do it because you're just doing this in your calculator to get to this answer. Sine of A is going to be 2 over root 5, so we're going to do the same thing. Take the inverse sine of 2 over root 5. That's 63 plus 43. So since we're taking the ratio of A to B, it says the ratio of the measure of the larger acute angle to the smaller acute angle. That's going to be 63.43 over 26.56. It's approximately 2.39, so it's answer D. The angle of elevation and depression. If you've seen my other video on this, you can realize that I just directly copied it from that to this. If you don't like it, again, sue me. All right. Angle of elevation and depression. Okay, angle of elevation, we have our little man here. He's going to be looking up at an object. This is the angle of elevation between the line directly, his direct line of sight, if he were looking straight forward, to his line of sight when he's looking at the object. That's the angle of elevation. Angle of depression goes from his straightforward line of sight to the line of sight that allows him to look directly at an object that's below his straightforward line of sight. Okay, it is important to know this because otherwise, if you get them mixed up, you will get an SAT problem wrong. So it says here this matters because you can know all the right angle trig, but you get the wrong answer because you didn't know the difference between the angle of depression and the angle of elevation. So here we have a car is parked 120 feet from a 350 tall building. What is the angle of depression from the top of the building to the car? We see that the building and street form a right angle, and tangent of theta is 120 over 350. Remember, tangent is the opposite over the adjacent. So this is the opposite, this is the adjacent. So we just take the inverse tangent of 12 over 35, because obviously we can just factor out a 10 on the top and the bottom, and that gives us 18.9. Are we done? Notice that that's one of the sucker punch answers, 18.9. No, we're not done. You have to subtract 90 degrees because they want the angle of depression, which is this here. That adds up to 90, so that's 90 minus 18.9, 71.1. That was the first mistake I made on that. It's the only mistake I actually made on those questions because I wasn't sure what the angle of depression was. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours. That's 240,000 minutes of view time in a year. So if you saw an ad during this, anything popped up, anything interrupted it, no, I didn't get any of that money. You can help me at least get some of this ad money. Seems fair. I'm creating content for YouTube. I should get at least a little taste of the ad money, right? And I don't have anywhere near 1,000 subscribers. For the same reasons, you are not only welcome, but encouraged to share links to this video, put in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos, and I reserve the right I'll try that again. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls or things that are off topic, spammers, disturbed people, etc. You can contact me on my cell phone at 415-623-4251. Texts are fine. Email me at john@johnlindenball.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. Hope you're having a good day. And if you think I've used something of yours that's copyrighted, I believe it's fair use, but you're welcome to contact me if there's some kind of problem. Okay, thank you.